Assalamu alaikum. We will continue on lecture 14. You remember we wrote the Laplace equation of continuity, remember? And we said that it's very easy to write it, but it's very difficult or complicated to solve it. So we decided to use graphical solution. Okay? Graphical solution. Solution by drawings. Okay? And we call it FlowNet. Okay? We will construct or draw FlowNet. FlowNet. I explained to you that FlowNet, it needs two types of lines. Okay? Two lines. I explained this previously, but I will repeat it again today. We will have one kind or one type of lines which we call flow or stream lines, and it should be represented by a solid line. Okay? And we will have equipotential line, which will be represented by this type of line. Okay? So these two lines will intersect each other to form a net. A net. Okay? Now, there should be some requirements to draw this net. We spoke about this. These requirements, they have to answer three questions. One question is the distance between the lines, right? The other thing is the form of shape, the shape that will be formed by intersecting the lines. And the third one is the size of our carpet, or the size, the area where we will work, right? Remember those three questions? Okay. Now, to solve them, we have these requirements. First of all of them, flow lines and equipotential lines should intersect perpendicularly. We solved this problem, okay? We solved one problem, which is the shape, okay? Because they should intersect perpendicularly, it means that there are two lines, right? These are, for example, one line, and this one line. This is wrong, right? Because they don't intersect perpendicularly, right? So they should intersect perpendicularly, okay? So we solved one problem. Because now we decided what is the distance between the lines, right? Once I put this distance, then I am forced to do this distance, right? Because I should intersect perpendicularly, one, and the other thing is they should form squares. Okay, so the shape, we answered it, okay? So, what do we have? We have to have lines that intersect perpendicularly and form squares, you see? So, equipotential lines and flow lines, they should intersect perpendicularly. Okay, they should form right angles, 90 degrees, and they should form squares. Because I may put it this way, okay? For example, these intersect perpendicularly, right? But we will have rectangle instead of square, right? So this is wrong. What should we have is squares, okay? Squares. So these two things, okay? One of them is they should flow lines and equipotential lines, they should intersect perpendicularly and they should form squares. These are requirements, very important requirements, okay? They should intersect perpendicularly. So this is, if you draw these type of lines, I will put wrong, okay? I will not accept it, okay? It's not acceptable to draw this type of angles, okay? They should always be right angles, perpendicularly. They should intersect perpendicularly, okay? And they should form squares. So this is wrong. This is right, because here I have square, I have square, I have square, but here it's wrong. Here it's wrong, okay? Now the third question, which is the size of our carpet, we will find it by determination of boundary conditions. Boundary conditions. Remember, I told you that I can give you the distance from here to the end of the room, right? You took this in descriptive geometry. We can tell you that a line 3 centimeters, okay, length. A line 3 centimeters long. Or I can tell you, draw a line with coordinates 0, 0, 0, 3, for example, or 0, 0, 2, 3, right? So I can draw it, whatever the length will come, Okay, so either I give you the length or I give you the coordinates. Okay, and here the same thing. Either I give you the size of the carpet or I give you the coordinates. We will give you the coordinates together. We will find the coordinates together. Okay, so now our job is to find the boundary conditions, which means that the size of our work, where we will work. Okay, let us move to next page. This is a question that I have, because I want to find the boundary conditions. Okay, now what does this mean? Okay, so this is rock, and then we don't have any water there, right? Okay, what does this mean? Water level. Okay, this is water level. Okay, so what do we have here? Or sheet pile or any structure that prevents water from flow through. Okay, what do we have here? Soil. Then water will come from here to this side. Okay, now I will put alphabet letters just to make things easy to us. Suppose this is the point A, this is point B, this is C, this is D, this is E, F, G, I, J, K, L. Okay, I did not use the letter H because H is the height, so I don't want to use it. Okay, we have this condition. You don't need to draw it now. Let us think about it, and then you will have time for drawing it. I have the point A, B. This is the level of water behind the dam, right? A, B. Okay, and then I have the line C, D, which is the interaction between water and soil. Okay, the beginning of the soil, the end of water. Not the end of water, because water is existing here, right? But this is the beginning of water with soil. Then I have the point E at the end of the dam. It's 1 point. And I have FG. It's the last portion of soil before going to just water. Okay, end of soil. JI is the height of water in front of the dam. Okay, KL is the beginning of rocks. Now, our job is to draw flow net here. Okay, the flow net, where it will be. Of course, it will not be in the water, because I'm not interested in flow of water in water. This is not my case. Okay, what I'm looking for is the flow of water in soil. So this is my area of work, the soil. Okay, water will go from here to there. Okay, now remember that we have to draw flow lines and equipotential lines, right? Now let us go back to understand what is a flow line. I told you, a flow line is the path of drop of water. Okay, how many drops of water here? Plenty of them. Okay, once I counted them, 721,872,911 and a half. Okay, don't forget that half. We have many drops. Okay, and these drops will go from here to there, right? And of course, you know that drops of water, they are not the students of An-Najah University. Students of An-Najah, when they want to go from engineering college to science college, they may go through the medical college, you know. They take their time, right? بالعربي بنسميها بيسنكحوا في الجامعة. They go everywhere. But water doesn't do the same thing. Water goes always from the shortest distance. This is the laws of water, laws of liquidity. Okay, they will go from the shortest distance. So, if we have, you have to imagine, or you just think of our Arab armies. Okay? You remember when they do march, in the time when the king sits down, when the king stands up, etc., when his birthday comes, when his, etc. You remember they go as marching, and they are extremely interesting to look at them, right? Because they, as if they are one body, right? You look at them marching, mashallah. It's like just one person, okay? When they move when they change their movement, they change it together, all together, right? This is the way the water goes. I think water studied this from the Arab armies, okay? So they go the same. I mean, it's not that one drop of water will come as the students when they go to the bus station or the, taxi station. It's almost impossible to find a taxi, right? You know this suffering, right? Okay. We all suffer from this, although it's easy to solve. I don't know why you don't solve this problem. Very easy. Very easy. You just put a sign here, say, this is to Ad-Dawar, to downtown. And this is to the university, okay? And then all students will stand in a line, okay? And every car should come to the first place. And whenever it comes, the first four will go inside. You will not wait for 5 minutes, you will be in a car, right? But we don't like orders. And once you stop here, the car stops there. Once you stop here, the car stops there. And you have to follow it. You remember this suffering. Okay. Water will go, all the water drops will go in one direction, right? Now, think about it. What is the shortest path that a flow line, that a drop will go? What do you think? What is the shortest? That's why I put these alphabets, to help you tell me. From where? D? D-E-F? Why not D-F? It's impossible, right? So if I want to go from here, okay, to the other side in the other room, I cannot go through, although it's shorter, right? But I have to go back to the door and then go to the other room, right? The same thing. Right, you are excellent. Okay, the drop that goes immediately on the sheet pile and goes up. This is the shortest distance that a flow line will go. Why? Because it will go just from along the sheet pile on the side, okay, and go up. The one near it will go. This will be bigger distance, right? Remember if you ever been in, this championship running, okay? And you know that they draw lines, okay? Lines, and then everyone will stand near the other. If it is for 100 meters, they will be near each other, right? Because they just will run once. But if it is a long run, 400, for example, or more, as you remember, they don't stand near each other. One is here and one is there, right? Why? Because the one in the inner circle will finish quickly. He will have a shorter distance to run, right? So that's why they calculated it, and they found that the one in the near line, he will be a little bit in front of him, right? You never raced? Did you ever been in a race? You just don't race unless you are catching the bus or catching sandwiches in our restaurant, right? The shortest flow line is what we call it? D-E-F. D-E-F is the shortest flow line. Okay, good. What about the longest flow line? The longest path ever that a drop will go through. Okay, wait a minute. Wait a minute. Don't panic. Okay? The longest. C, K, L, G. Did you ever saw a drop of water going like this? You know the path of water, why it comes like in a circle or in semicircle way? Because, guys, gravity and go out. It needs to go out. Energy, right? Then the resultant, okay? Then gravity, go out. Resultant. Then etc. So it comes like this. It's like semicircle, okay? But there is no water comes down, then goes, then it doesn't happen, even in dreams. So guys, what do you think? C, E, G. Okay, good. C, E, G. Water will come like this, then come like this. What about those? They will intersect each other. That's no way. They are all together here and they will go together. All of them. No. I'm not convinced. See what? Say CKL? You just said it and we said no, it's not. E, F, right? This is F. Okay, now the shortest, we already put it, the shortest. This is the shortest. The longest. Guys, the longest path of the water, of any water drop, is the path that the water drop will begin somewhere there, because I didn't draw all the river. I just draw some of it, right? I didn't draw all the river. So the longest path is that a drop of water, it will come from Tulkarim, okay? And then it will go all the way. KL is part of it, and then it will go out from Amman. Did you understand it? KL is part of the longest ever path of any drop, right? You get it? KL is part of the longest path. So, KL, the longest is KL. So all our lines will be between DEF and KL. I cannot go beyond KL or DEF, right? All my drawing will be just between DEF and KL. So my drawing will be somewhere here, and that's obvious, that's okay, right? All my drawing will be between this line and that line, okay? How many lines I can draw? As much as you can. And I can more. Okay? But of course, this we will come back to what? To the idea I told you once. To draw a line, we need a minimum of 2 points, right? To draw a curve, we need maybe 3 good, maybe 4 is better. So I need a maximum amount of minimum points. I mean, minimum points that gives me the best idea. Okay? So instead of drawing 700 million blah, 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 blah points, let them be, my advice for you, between 4 and 6 lines. If you will take this advice, free advice. Always make the flow lines between 4 and 6. Okay? Because, by the way, additional 1 line will make your life more complicated. And I think it's complicated enough without that. You don't need it, right? So you don't need this additional misery. Make your flow lines between 4 and 6. Okay? So I will draw flow lines here. Okay? Acceptable? No, I don't like it. Maybe it's good. What was the letter there? No, this is not K. G. G. Okay. I draw several flow lines, okay? Several flow lines to represent the millions of flow lines that can be drawn here, right? Now, what I should draw also, this is not a net. I need the other line, which are equipotential lines, right? Equipotential lines, they should be, okay, that's one. They should intersect with flow lines perpendicularly. They should form squares. But first, let me see, or let us find what is the first equipotential line and the last equipotential line, right? We are looking to the boundary conditions. What is the first equipotential line? And let me remind you of what is equipotential line. Equipotential line is the line where potentiality of every point on that line is equal to other, right? It's constant. Potentiality of all lines is the same. I mean, if this line, I will put water over it, water will rise to the same level because this line can rise water due to its potentiality to the same level because all points of this line are similar in their potentiality, constant in their potentiality. Understand that? And of course, we are not talking about water. We are talking about soil and water. So, the first equipotential line, the first meeting between water and soil, and where the water will rise above that line of soil to the same height. What is the first equipotential line? سيدك. الله يرحمه. Why CD? Do you agree with that? Don't. CD. Why CD? Do you agree, CD? You agree? So I do agree also with you. KL, we said that it's flow line. Flow line cannot be an equipotential line at the same time. So CD, okay. CD, first interaction between water and soil. The other thing that CD is the line that has a potentiality to raise water above it to the same height, right? So it's right. CD. And CD should be drawn this kind of line, but it's not seen because of the line of the water, of the line of the soil. Okay, but if you look in depth, you will find it different line. Okay, so CD is the first equipotential line, CD. Okay, last equipotential line. The end of the relation between water and soil. FG, this one. FG. Do you agree? All? Do you agree? Right. FG, last. So, guys, look. Flow lines. We have the first one, the last one. The first one is the shortest, which is DEF. The last one is KL, part of it. All my flow lines should be between DEF and KL. The first equipotential line is CD. The last equipotential line is FG. All equipotential lines should be drawn between them, right? So, now I will draw equipotential lines, okay? The first one is already drawn, right? The second one, now, I should intersect perpendicularly. By the way, this is right. This is perpendicular, you see? Perpendicular, you see? I should intersect perpendicularly first, I should form squares, right? And I should be between CD and FG, right? So let me draw it. This is perpendicular, almost this is a square, right? I will continue. Okay, this is perpendicular, perpendicular, perpendicular. This is a square, this is a nice square, you see? If you don't see it as a square, suppose it's a square, okay? Wow, very nice. You see how beautiful this square or this square? We will not concentrate a lot on this. Okay, guys, now I draw several equipotential lines and several flow lines in the area between DEF and KL and the area between CD and FG. You will not find any flow line beyond DEF or KL, right? You will not find any equipotential line before CD or after FG, right? Okay, and all lines intersected each other perpendicularly and formed squares. Maybe it was not drawn very well, but I mean, I tried my best. That's why it's not very easy to draw it. Okay, but even computer now can draw it. Okay, I made it. I constructed a FlowNet. No gifts? Okay, I don't need gifts. FlowNet. I have a very nice FlowNet. So, do I have to celebrate? No, because I want to use it. How I will use it? How I will use this FlowNet? Just before using it, I need to answer from you to answer me in 2 questions, okay? If we knew them, that's good. And everybody has to know them because everybody has a hand. And in his hand, he has fingers, right? And I think he can count 1, 2, 3, 4, 5. He doesn't need more than 2 hands. If he needed, he can borrow from his neighbor. But I don't think that he needs more than 1 hand in some cases, maybe 1 hand and half. Okay? Let us, tell me please, how many flow lines I have in this drawing? 3, 4, 6, until now I heard 4. How come? This is not 4. She's telling me 4. Which one of them? 4. Huh? You see? 4. How many? 4? Why not 6? Why not 2? I heard 2, I heard 4, I heard 6. And I will put from myself 5. Just not to be just in even numbers. How many? How many flow lines do we have here? Guys, if you counted them wrong, all your solution will be wrong. All your solution will be based on counting well. Okay? Counting well. All your solution will be based on counting. If you made a mistake in counting, all your question will be wrong. And you will see that. How many flow lines? Last trial. How many flow lines? 9. Who says, who's with 9? Not even the one who said it. Okay? Because you are sitting near him, friend. Did he invited you to pizza? How many? 9. 2 says 9. I don't know from where they get this 9. Okay. Who says something else? 10. Who's with 10? Who's with 10? Nobody, not even you. 3. Guys, 3. Flow lines. How many flow lines? How many flow lines? 6. 9, 10, 3, 6. Who's with 6? What about you?
مش عارفين.
بحكي عن الرسمة الموجودة هون. In this drawing, how many flow lines do we have? 4. Who's with 4? Majority of 3 out of 32. This is a good democracy. How many flow lines? How many flow lines? 4. 4. Who says 4? 4. Let us count them. Why to bother too much? Let us count them. Okay. The first flow line is this one, right? The second flow line is this one, right? The third flow line is this one, right? The fourth flow line is this one. 4. Why do you have to bother too much? 4. There are 4. 4 flow lines. So I have flow lines equals to 4. 4 flow lines. Guys, if you counted them 5, you will see that all your solution will be wrong. I have 4 flow lines here. Don't forget the first and the last one. Okay? I have 4 flow lines. How many equipotential lines I have here? 6, 7, 5, 5. Okay. I got it. 5. Why 5? Okay. 1, 2, 3, 4. This one is 2. 1, 2, 3, 4, 5. Change your mind, right? You changed your mind. 7. Why you didn't consider this one? It's not 1. Because this one is here and that one is there. Okay? So I cannot consider this one is 1. This is 1 and this is 2. Right? And this is 1 and this is 2. So now what do we have? We have 1, 2, 3, 4, 5, 6, 7. So there are 7 equipotential lines. Are you convinced? Anybody has questions? Even a question? Anybody doesn't have any question?
إذا ذاك الخط تحت البوتنشال برضه بنحسب نقسم لقسمين تحت هاي الدام يعني
ما راح يكون.
There is no such case. If you find it, ask me. So we have how many equipotential here? Equipotential lines equals 7. Flow lines equals 4. If we count this wrong, then all our solution will be wrong. Okay? So, guys, we have to draw the flow net correctly, and then after that we have to count how many flow lines do we have, how many equipotential lines do we have. Okay? Let me ask you a question. How many flow lines do we have here? 4. Yeah, we see it. 4. Okay. So how many flow areas do we have?
3.
How many flow areas? 3. Guys, is all areas always equals to n minus 1, right? Remember that? Remember that if we have a straight line, we have points at same intervals, and we have 10 points. So what is how many areas? 9. N minus 1, right? It's 3. Remember, look, I will draw them for you, okay? This is a flow line, right? This is 1. This is the second flow line. Flow area, sorry. And this is the third flow area, okay? So I can say flow areas equals 3. It's always number of lines minus 1. How many equipotential areas? I can say immediately equipotential areas 6 because 7 minus 1. But let me check. Okay, this is 1 area, 2, 3, 4, 5, 6. 7 minus 1, 6. Okay, guys, number of flow areas equals to number of flow lines minus 1. Number of equipotential areas equals number of flow equipotential lines minus 1. Okay, or I can even find them by myself. 1, 2, 3. 1, 2, 3, 4, 5, 6. You will not be able to see anything anymore. Right? So, what do we need from the flow net? The most important thing. To draw it well by knowing the shortest flow line, longest flow line, first equipotential line, last equipotential line, and draw lines, flow lines between 4 and 6. Here I draw 4, right? If I made them 5, you see it will be trouble. So make your flow lines, this is an advice. It's not a must. Okay, it's an advice. Make your flow lines always between 4 and 6. Okay? I draw the net. Now I have to count number of flow lines, number of equipotential lines, and find number of flow areas and number of equipotential areas. Okay? Okay. By the way, number of equipotential, number of flow areas, I call it FA, right? Flow areas. But I may use from now on NF, number of flow areas. And here I will use ND, number of equipotential areas. Okay? So what is ND? Number of equipotential areas. What is NF? And these are very important. These are the basic. If you miss them, you will miss all the solution. Okay? Let us check what do we have here. Okay. This is obvious. Okay? We know it. You wrote this, right? Now let us go to page. Next page. See, I draw a flow net. I draw a flow net. How many flow areas do we have here? 3. Okay. How many equipotential areas?
6.
Flow areas, equipotential areas. 6. So NF equals 3. ND 6. Okay. Good. Now I have to draw this. I know how to draw this. How to use flow net. This is our next session. Okay. How to use flow net. We will explain this later. Okay. We will know how to use. There are 3 usages of flow net. Okay. We knew how to draw it. We knew how to know it, to understand it, right? How to use it. 3 things we have to use them. This will be explained next time.